were trained. The results are given below. This is the data. They have taken 5 students, and for this 5 students, they have given a training. So before training, their IQ levels are this much, and after training, their IQ levels are this much. And now they ask you, test whether there is any change in IQ after training program. Use 1% level of significance. This is the question. Yeah, which test can be used?
T-test for paid samples.
Why do we need to use t-test for paid samples?
Two samples are given, less than 30. Also, before and after is mentioned, so we use paid T-test.
Yeah, before and after mention, and if they have taken a different set of a sample, is it okay? Can we use the paid t-test?
No, ma'am.
No. So we have taken a same sample, and for that same sample, we have taken before training what is IQ level and what is after training the IQ level they mentioned. Right now, for this one, how to do this one? There is an inbuilt function for this. No need to do anything. So here, what it is? Just go to the data and go to the data analysis, and then here you just check it. Paid t-test. Yeah. T-test paid to sample for means. Select this, then OK. And variable 1 range before training, I'm selecting. Variable 2 range after training, I'm selecting. The data can be in a rows or columns. You can enter as ever you want. Next, go to the hypothesis difference 0 and labels I have selected in the first row, and then give the output range. Okay, so here I'm just giving the output range.
Ma'am, alpha is 1%.
Where it is? I didn't get it.
Alpha.
Alpha is 1%.
Okay. Yeah. Very good. Thank you, dear. Yeah, I haven't seen that. Yeah, use 1% level. So 0.01, and then okay. Now this is the data. This is the output. You got it. Now write the procedure, everybody. So what is the procedure here? Here, write that. Write the procedure. Step 1, null hypothesis. What is the null hypothesis? Can anybody tell me?
mu1 is equal to mu2.
Yes, mu1 is equal to mu2. I'm writing in words only. Mu1 is equal to mu2. Okay. And step 2, what is that? H1, construct the alternative hypothesis. What is that here?
mu1 less than mu2.
Very good. Mu1 less than mu2. Why we are taking less than mu2? Because see, you need to think logically before writing the alternative hypothesis. Here they are asking that IQ level always, if you are giving the training, we expect that the IQ level will be increasing, right? That's what we are taking less than. That means first IQ level before training is less than to the IQ level after training. Okay, so it is a left-tailed test. And then move to the step 3. What is the step 3? Level of significance. What is the level of significance they gave? 1%, 0.01. And then what is the fourth step? Degrees of freedom. What is the degrees of freedom?
n-1.
N-1 or N-2? I have a doubt in it. Is equal to N-1, 5 minus 1. So you just check it. It is a 4. And next go for the test statistic. Okay, go for the test statistic. So what is the test statistic here? Here test statistic is nothing but directly you got it here. Just write that T-cal is equal to. What is the T-cal value? Here T-cal is equal to here T-stat. What you can see? This is the T-cal value. Okay. So T-cal value is equal to what? This value is equal to, copy this value as it is. Okay. T-cal value means this value. Okay. And then move to the table value. Next step. Next step, table value. Are you understanding, everybody? Here we are not doing anything. T-cal value directly is there in the table. Just copy it and then go for the table value. So T tab is equal to also here T tab. One tail value we need to take. Here we are taking the left tail. Here it is a one tail. So one tail means it is what? It is a left tail. Left tail means we should have a negative value. Is it right, everybody? Left tail means what is
Yes,
that?
ma'am.
Negative we should have. So is equal to, oh, what is that here I'm writing? Is equal to this critical one tail value into minus 1. Okay, you got the table value. Did you understand? Did
Yes,
you
ma'am.
Yes,
understand,
ma'am.
Yes,
everybody?
ma'am.
If it is a left tail, that's what we are taking into minus 1. If it is a right tail, we'll take as it is. Okay, and then go for the conclusion. So what is the conclusion? Can anybody tell me what is this left tail test conclusion? 1 minute, let me draw the curve. Oh God. Yeah. So suppose if you are having left tail value. Left tail value means this is the curve you will be having. T-test curve is like this. Okay, this is t is equal to 0 and minus infinity plus infinity. Left tail means left side you will have a critical value. This is a minus t alpha. Okay, and see when you are accepting and when you are rejecting the null hypothesis, you just tell me the t cal value where it should be after this minus t alpha or
Greater
before
than
this. Yeah, t cal value
before.
where it should be greater than to the t alpha, that is t tab. Is it right?
Yes,
Is it
ma'am.
right, everybody? This is a table value. So when we are accepting the null hypothesis, if the t cal value comes here, if the t cal value comes here, that means what is that? T cal value should be more than to this table value. Understanding? Everybody?
Yes, ma'am.
So if t cal value is more than this table value, then we are accepting H naught. Otherwise, reject H naught. Did you understand? Is it clear how to give the conclusion?
Yes, ma'am.
Yes.
Yeah, now write the conclusion is equal to if, open the bracket, then what is that? T cal value should be greater or lesser to accept.
Greater.
Greater.
Greater than T tab. Then what will do if T cal greater than T tab? What will do?
Accept H naught. Accept H naught.
Accept H naught. Otherwise, what you will do? Reject,
Reject
Reject
H
H.
naught.
yeah, reject H naught. Okay, this is the conclusion. Did you understand, everybody?
Yes, ma'am.
Yes, ma'am.
Yeah. So conclusion is this. So that what is the statement will be given? Accept H naught means what is the statement?
There is an improvement in IQ level.
There is an improvement. Accept H naught, dear.
Change in
Accept
IQ
H naught.
level.
There
There
is
is
a
no
change.
change.
Yeah,
There is
equal
no
to means
change.
what? There is no change. What is the statement you need to write? There is no change in IQ level. IQ level after the training. Did you understand what is the statement? Is it clear?
Yes, ma'am.
Yes,
Any doubt in this? Is it clear, everybody?
Clear, ma'am.
Yeah. Now go for the next question. Okay, let me explain this. Yeah, this is a question. Next question. Yeah. What they have given, test the significance of Carl Pearson's correlation coefficient to the following data. They have given you the R value and the N value. Then how can we do, which test we need to apply? First understand.
T-test for single correlation coefficient.
Yeah, t-test for single correlation coefficient. Why we are using t-test? Here we need to test the correlation. They asked you clearly. Just to test the significance of KPCC, they asked you. So Carl Pearson means you can apply either the Z test or the T test. There are only two possibilities. And if the sample size is more than 30, then only we can apply the Z test. If the sample size is less than or equal to 30, then only we'll apply the T test. So here you just check it. In this data, the sample size is less than 30 and you need to apply the KPCC test. Then the appropriate test for the data is T test for single correlation coefficient. Is it clear, everybody?
Yes, ma'am.
Yeah. Now tell me, what is the procedure then? Yeah, T test for single
Rho is
correlation
equal to rho.
coefficient. 1 minute. T test for single KPCC. Yeah. What is the step 1? H naught. What is the step 1?
Rho is equal to rho naught.
Rho is equal to rho naught. Next, H1.
Rho naught equal to rho naught.
It can be not equal to or a greater or a lesser. And step 3,
Level of significance.
level of significance. Step 4,
Degrees of freedom.
what is
N
that?
minus 2.
N minus 2. Very good. And what is the test statistic?
R minus rho naught by under root 1 by R 1 minus R square by N minus 2.
R minus rho by under root 1 minus R square by
N minus 2.
N
N
minus 2.
minus 2. T N minus 2 degrees of freedom. This is the formula. And next you know that table value. And next you know that conclusion. Okay, so these are the steps. Now you just do the calculation here, the same step. First one, what is the first step? First step, null hypothesis H naught. What is that? Rho is equal to rho naught. Go to the insert symbol. Can I get a rho here? Okay, you have to check it. Check it. Can you see anywhere rho? Check a rho symbol. Can you see anywhere? P value. Alpha, beta, gamma, delta, eta, theta. Yes, here it is. And yeah, rho is equal to. Now tell me what is the rho is equal to? What is it here? What do you have to take? What do you have to take?
0.
Yes, here they did not mention means we'll take rho is equal to 0. And step 2. What is the step 2? Alternative hypothesis. What is alternative hypothesis here?
Not equal to 0.
Yeah, rho not equal to 0. They did not mention whether it is a greater or a lesser. So we'll take not equal to 0. Okay, not equal to 0. Here what is this? Go to the insert symbol, not equal to close. Okay. So what is that? Rho is not equal to 0. And go to the step 3. What is the level of significance alpha? Alpha is equal to, they did not mention means it is a 5%. And step 4, it is what? Degrees of freedom. What is the degrees of freedom? N minus 2. They have given n is equal to 8. 8 minus 1, 8 minus 2. Degrees of freedom. N minus 2 is the degrees of freedom. And then go to the test statistic. Test statistic. So here you need to calculate test statistic. T-cal is equal to, what is the T-cal? There is no inbuilt function for this KPCC. So you need to do manually only. What is the formula? Is equal to numerator R minus rho. R is what? Here. Let me write. Oh, sorry, I forgot to write the given values. Here I'm writing given values. Given values. R is equal to 0.8423 and n is equal to 8. Okay. Now write the formula is equal to, open the bracket, r minus rho. Rho is a 0. See, check it. Under H naught you have taken 0. Close the bracket. Divided by square root of, and for the numerator, what is the formula? Square root of?
1
1
minus
minus
R
r square
square.
by n minus
Very
2.
good.
N
1
minus
minus
2.
r squared. 1 minus r square. 1 minus r square. Close the bracket. Divided by. Open the bracket. N minus 2. N minus 2 is the degrees of freedom only. I'm taking directly degrees of freedom. and then close the bracket, enter. Yeah, got it everybody? Understood what is the correlation value? Is it clear?
Yes, ma'am. Yes, ma'am.
So what is the correlation value? It is a 3.82. Okay, tcal value, sorry, tcal value. And after that, what do we have to do? What is the next step?
Table value.
Yes, table
Values.
value. Tell me what is the table value? How can we do the table value? It is a two-tailed. Then what is the table value? T tab is equal
TINV of
1 minute. T tab is equal to TINV. Open the bracket. Then it is a two-tailed. Then what do you have to do?
alpha,
Yes,
comma
alpha
degrees of
as
freedom.
it is. Alpha for two-tailed alpha as it is. For the single tail, you need to multiply with the 2. 2 into alpha for the right or the left tail. Is it clear? Yesterday I told you.
Yes,
Did you remember?
Yes, ma'am.
yes, ma'am.
Yeah, alpha comma degrees of freedom. Then close the bracket. Enter. Yeah, you got a TIN table value and go for the last step. It is a conclusion. So what is the conclusion here? Write that is equal to if, open the bracket. Here tcal value is positive only, so no need to take the absolute, take as it is directly. So if tcal less than t tab, then comma. So accept H naught. Okay, accept H. 1 second. Hello. చెప్పు. నాకు ఫిఫ్త్ అవర్ లీజర్ ఉన్నాను, ఫిఫ్త్ అవర్ ఇస్తాను కంటిన్యూ. ఇప్పుడు థర్డ్ ఫోర్త్ సిక్స్త్ ఉంది నాకు మినిమం. ఇప్పుడు క్లాస్ లేదు మినిమంకి, నువ్వు ఇప్పుడు చెక్ చేసుకోవచ్చు. Yeah, so what is that? If t what do you have this? If this one t cal is less than t tab, then accept H naught, otherwise reject H naught. Yeah, reject H naught. Conclusion. So what is the statement can be given? What is the statement? Check that. Rho is not equal to 0. Not equal to 0 means what? There is a significant difference. Rho is equal to 0 means what? There is no significant difference. Rho is not equal to 0 means what? There is a significant difference. Is it clear?
Yes,
Did you
ma'am.
understand? There is a significant
Yes.
difference between the correlation between the KPCC. Is it clear? Any doubt?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes. And now this is what, with raw data or without raw data?
Without raw data.
Without raw data.
Data.
Yes. If it is a with raw data has given, this is the data. So just check it. This is a with raw data. Now in this case, what to do? The same procedure will continue here. Same procedure will continue. But only the change, there is a one small change. What is the change? Here, you just check it here. In place of here, correlation value, they did not give you. You need to calculate. Okay. So here, what is that? Tcal value and the t tab value. Okay. Conclusion, delete it. And degrees of freedom also will change. So what is the given? What is the n is equal? How many observations are there? Count. How many? Check it here. 8 observations. Okay. So what is the degrees of freedom? N minus 2. That is 8 minus 2 degrees of freedom. I got it. And then what is the tcal? You know the formula. What is the tcal formula? R minus rho by under root 1 minus r square by n minus 2. So you need to know what is the r. So you need to find the correlation here first. Okay. You need to find the correlation. So how can I find r is equal to? How can I find correlation? CORREL. Correlation, open the bracket. It is asking what is array 1. This is array 1. Okay, comma. What is the array 2? Okay, this is the array 2. Okay, then close the bracket. Enter. Got it, everybody? What is the correlation value? In the previous problem,
Yes,
correlation value they have given to you. But here, they did not give you. They gave you the raw data. So you need to find the correlation. Did you understand? Is it clear?
Yes, ma'am.
Yeah, how you are finding the correlation? Once again, I'm telling you is equal to CORREL. Open the bracket and see the data can be then either in a row or a column. It can be anything. Then you just check it correl and take the first row. That means array one means first data, comma second row. That means second data. Then close the bracket. Enter. You got the R value. Now tell me what is the formula? TCAL formula. What is the TCAL formula? Come on, dear. What is the TCAL formula?
R minus
R
rho by
minus rho naught by under root
Yes.
1 minus R square by
R.
N minus.
R minus rho is what here? Come on, dear. What is the rho?
0. 0.
Hmm.
0.
0. Close the bracket divided by square root of. Open the bracket. Open the bracket for the numerator. What is that? 1
5.
minus R squared. This is R hat 2. Close the bracket and divided by n minus 2, that is degrees of freedom only 6. Close the bracket, then enter. Got it?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Now, what is the table value? It is a two-tailed value, TINV. Open the bracket. Then, suppose here I want to check it this one here. For example, I'm telling you. Here instead of not equal to, I want to check it as a greater than. Okay, less than 0. This is I want to check it. Then now tell me what is the table value.
Is equal to
It is
T
a
2
table
into
value. TINV. Open the bracket. 2 into
Alpha.
alpha
2 into alpha, comma,
into minus 1.
degrees of
Gamma
freedom
degrees of
degrees of freedom. Close the
Yeah.
bracket. That's it.
into minus 1.
Minus 1.
Yes, into minus 1. Did you understand, everybody, how to write the single tail table value?
Yes, ma'am.
yes. Yes.
And you know the conclusion. That's what I'm not writing. I hope you know the conclusion, right? Okay, let me tell you. What is the conclusion? It is a left tail. Okay, left tail. Conclusion is what? If, open the bracket. Tell me.
TCal greater than
Very good. TCAL greater than
T tab.
T tab.
TTAB. Then what will do?
Accept H naught.
Accept
Accept H
H
naught.
naught.
Accept H naught. If not,
Reject H naught.
Reject H naught.
reject H naught. Okay, got it? Everybody understood? Yes?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So we finished this t-test for correlation. Now we finished with the C. We finished the t-test for single mean, difference of means, paired t-test and correlation. So the t-test, complete t-test we finished. Then now we are entering into the chi-square test. Okay, we finished the last sample and we finished the t-test. Now we are moving to the chi-square test. And today 6 hour I'm taking a class here. Today I want to finish this entire Excel and tomorrow I'll start this R practicals. Okay, tomorrow I'll start our practical. So today I want to finish this entire Excel. So mostly it won't take much time. Hardly it will be taking a half an hour, not more than that also. So now in this period I cannot finish it off. So that's what I'm taking in the 6th hour. Is it clear?
Yes, ma'am.
Yes, ma'am.
And to finish our programming, definitely I need a 3 to 4 classes again. 3 classes the minimum I need. So that's what I'm taking today. And now go to the next date. Something I did. Okay. Next one, you just check it. What is the data here? You have weights of 10 students are 38, 40, 45, 53, 47, 43, 55, 48, 52, 59. These are the weights of 10 students. Can you say that variance of the distribution of weights of all students from which the above sample of 10 students was drawn is equal to 20 kgs. So tell me what are the given values?
N is equal to 10.
Okay, n is equal to 10. That's fine. Next. Hmm.
They gave
Yeah,
raw data, ma'am.
raw data. Okay, next. Okay, raw data. This is raw data. Very good, perfect. Next. That's only, they did not give anything else.
Sigma square is to 20 kg square.
Yeah, here what they mentioned. Can you say that variance of the distribution of weights of all students from which the above sample of 10 students was drawn is equal to 20 kg square? They mentioned it is a this 20 kg square is what? It is a variance. So it is a population variance. So here what I'm writing here, population variance is equal to, what is the population variance? It is 20. Did you understand? Is it clear?
Yes.
Yes, ma'am.
Yeah. Now enter the data. Okay, here I'm entering the data. The data they have given it is what? Okay, weights of a students. I'm writing here. Okay, let me write weights of a students. So what is the weights of those 10 students? 38, 40, 45, 53, 47, 43, 55, 48. What is the next? 48,
52.
52, 49. Yeah. And after this, and see, okay, this is the raw data they have given to you. I have entered into the row, in the column, in the first column. Okay, somewhere I have entered. And now you just tell me, this is the data has given. What is an appropriate test to test the given data? They asked you to test something.
F test.
Chi-square single variance.
Yes, F test when we'll apply here, F test we apply only if we have a two samples to test. F test is also used to test for the variance only. That is perfect. But when we apply the test, F test, if we have a two samples, but here only we have a one sample, and that sample you need to test through the variance. So which test we can apply?
Chi-square test.
Square
Chi-square
test.
First single.
test. Very good. Okay, now you just tell me what is the procedure for the chi-square test? Yeah.
Null
Now you
hypothesis.
just tell me. Okay, 1 minute. Chi-square test for single variance. Tell me, what is the step one?
Null hypothesis.
Null hypothesis. What is this statement?
Sigma square is equal to
Sigma square equals to sigma naught square.
Very good. What is the step two?
alternative
Sigma
hypothesis.
square greater than sigma naught square or less than
Sigma
or not equal.
squared, it can be a not equal to sigma naught squared, or a less than, or a greater than. What is the next?
Level of
Level
significance.
of significance.
Level of significance. What is the level of significance? Alpha, it can be any alpha percent, either 1% or a 5% or a 10%, right? And next,
Degrees of freedom. N
Degrees
minus
of
1.
freedom.
yeah, degrees of freedom. What is the degrees of freedom?
And my
N minus
and
1.
yes,
Hmm.
Minus 1.
N
N
minus 1.
minus 1. Okay, fine. What is the next?
Test statistic.
Test statistic. Okay, test statistic is what?
N is a square by sigma square.
Yes.
MS
See,
square, sigma square.
1 minute here, something happened. Yeah, tell me what is the test? 1 minute. Yeah, tell me what is the test statistic? Chi-square cal is equal to ns square by sigma square, which follows chi-square n minus 1 degrees of freedom. Now you just tell me what is the smallest square?
1 by n summation over I is equal to 1 to n xi minus x bar whole square.
Yes, very good. 1 by n summation xi minus x bar whole square. Fine. Okay, you need to calculate this value. And sigma square value anyway will be given in the under h naught. And next you just go for the table value. And next we'll go for the conclusion. And now here I want to know if it is a C. If chi-square distribution is a which type of a distribution?
Positively skewed.
Positively skewed.
Positively skewed. Okay, so positively skewed, this is the curve. Okay, this is the curve and it is 0, it is minus infinity. Suppose if it is a two-tailed, now tell me, if it is a two-tailed, then what do you have? This is a one tail and here also one tail. Two sides will have a rejection region. This value how can we find and this value how can we find? Tell me.
chi-square 1 minus alpha by 2.
Okay. And here and comma degrees of freedom, right?
So ma'am, here it is
Alpha by 2
Yeah.
comma.
That is you
Left
need to
side one.
remember. Left side it is a 1 minus alpha by 2 and right side it is a alpha by 2. Okay. So based on this you need to do the calculation. So here also now go to the calculation part. Why I told you I'll let you know. Here you just go for the procedure. Now write that what is the step 1 H naught. What is the H naught? H naught is what? Sigma square is equal to sigma, yeah. So sigma square is equal to what? Tell me what is the sigma square?
20.
Here. Yes, sigma square is equal to, what is the population variance here? You just check it. Here they mentioned population
20.
variance is sigma 20. So write it here, sigma square is equal to 20. And what is the step 2? Alternative hypothesis. So what is it? The same thing will be taken, but what is the alternative hypothesis here? They did not mention. Then what will
Not
take?
equal to 20.
Not equal to. Okay, let me take a symbol. Not equal to. Yeah. What is the step 3?
Level of significance 5%.
Yes, alpha. They did not mention anything. So it is a 5%, which is equal to 0.05. And next one, what is the step 4? Degrees of freedom. So what is the degrees of freedom? N minus 1, N minus 1. Okay, 9. And what is the step 5?
Test
Test
statistic.
statistic. Okay, what is the, in that test statistic, you know that, what do you have written test statistic formula?
NS
Yeah,
square by
ns
sigma.
square by sigma square. You have written that. So n is known to you, that is 10. Sigma square it is known to you 20. And s square value they did not give you. You need to calculate. Okay. So how can you calculate? Here write that sample variance. Okay, let me write s square. Small s square is equal to. How can you do? See, variance of, see, variance P you need to write. See, this one you need to select. Not only the variance. If you are taking this only the variance, it will be giving you the value of 1 by n minus 1. But what is the small s square formula? 1 by n, right? So the students does a mistake here. It is not a variance. You need to take variance of P. If you want to calculate the small s square, you just use the variance of P, this one. Okay, understood everybody? Is it clear?
Yes,
Yes.
ma'am.
Yeah, if you want to calculate small s square value, use the variance of P. If you want to calculate capital S square, use only variance. Okay. Then after that, select the data. Yes, select the data. Then close the bracket, enter. Got it?
Yes, ma'am.
Yeah. Now you just calculate the chi-square cal value. So what is the chi-square cal value? Just do the calculation is equal to n. N is 10 into s square. S square already is here. Divided by sigma square. Sigma square already they gave 20. Then enter. Did you understand what is the chi-square value? How to do? Once again I'm telling you is equal to n into s square divided by sigma square. Enter. Got it? What is the chi-square value? Is it clear?
Yes, ma'am.
Yeah. After this, go for the next one, table value. Listen this carefully. Table value. So, table value. Table value will differ here. Okay, table value is what? P tab is equal, sorry, chi square tab is equal to chi tab. I'm writing. Chi square means it is taking little place. Yeah, chi tab. Here you need to write for the right tail and the left tail. It is a two tail means you need two table values. For the what is that? For the Z and T distributions, we didn't take a left tail value separately because anyway the tail, the same value will be taken with the negative value. That's what we haven't taken, and by using the right tail only we have given by using the right tail table value only we gave the conclusion because of the symmetricity. But here chi-square is not a symmetric one. It is a positively distributed. So you need to take, it is a right tail and left tail, both the table values to give the conclusion. Okay. So here write that for the right tail. So right tail value is equal to what? Is equal to PINV. Sorry, chi-inv. We are in a chi-square distribution. So that's what? Chi, CHI-INV. Okay. Open the bracket. What is the probability? See, what do we require? For the right tail, we require, do we need alpha by 2 or 1 minus alpha by 2?
Alpha by 2.
Alpha by
Alpha
2.
by 2.
Yes, alpha by 2, comma. Degrees of freedom is what? This 9. Close the bracket, enter. Did you understand? Do you understand, everybody? Yeah, for the left tail, what is the left tail now? You just check it. Is equal to chi inv. Open the bracket. 1 minus alpha by 2. Alpha by 2 is what? 0.05 by 2. Okay. Comma. Degrees of freedom. Close the bracket. Enter. Did you understand what is the left tail value?
Yes.
Yeah. Now, after this, after finishing the table value, I hope everybody understood this. How to find the right tail and left tail for the two tailor test. Is it clear?
Yes, ma'am.
Everybody
Yes,
in
ma'am.
the class?
Yes, ma'am.
Yeah. Now move to the step 7. It is a conclusion. So how can we do the conclusion? Is equal to here. What is the conclusion? Tell me, dear. What is the conclusion? How will be giving? If it is a two tail, then what is the conclusion?
If chi-square 1 minus alpha by 2 is less than or equal to chi-square can less than or equal to chi-square alpha by 2.
Yes. Yeah, here it is there. This is the acceptance region and this is the rejection region and this is the rejection region. Now tell me, when you are accepting, if the chi-square cal value should be lies in between these two, right? So what is that? Chi-square cal value should be less than to the chi-square, sorry, left tail value should be less than to the chi-square cal value and chi-square value should be less than to the right side table value. Is it clear? Is it right?
Yes, ma'am.
Yes. So this is I'm writing like this. This entire thing we cannot take directly. So I'm writing like this. Chi-square left tail value less than chi-square cal and chi-square cal less than chi-square right tail value. Can I write? Can I split this equation like this?
Yes, ma'am.
Yes, ma'am.
Yes. So I'm writing like that only. Check it is equal to. What is the value? Chi-square. Okay. See if open the bracket, you need to check both the two conditions you need to check. That's what I'm writing. And okay, two conditions you want to check simultaneously. That's what mentioned. And open the bracket. If the what is that chi-square left tail value less than chi-square cal value. Okay, comma. Another condition is what? Chi-square cal value less than chi-square right tail value. Did you understand everybody how to take? Is it clear?
Yes.
First, what I have taken, okay, once again, let me tell you. So what I'm taking is equal to, if, open the bracket, here you want to check the two conditions because it is a two-tailed test. You want to check the two statements. So that's what I'm taking, and, open the bracket. So what is that? First condition, chi-square left tail value is less than chi-square cal value, comma, chi-square cal value is less than chi-square right-tailed value. If these two conditions satisfies, okay, if these two conditions satisfies, then open the quotation, accept H naught, close the quotation, comma, otherwise reject H naught. Is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, so accept H naught. That means what is that? The sample has drawn from the population which is having a variance is 20 kg square. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes. Any doubt anywhere? Is it clear, everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. So chi-square test for single variance we finish when if the raw data has given to you. So suppose if they haven't given you the, it is what? With raw data. Yeah. Without raw data means what is that? They only will be giving you this S square value and directly you need to substitute the value here. No need to calculate this one. Okay, that's what I haven't given you the question for separately for the raw without raw data. Is it clear? Because if it is a raw data, there is no inbuilt function. So that's what you are doing the calculation separately and doing the chi-square cal value. If it is a raw data means S square value also will be given to you. So directly you can substitute. Is it clear?
Yes, ma'am.
Okay. Yeah. So now you just tell me what is a right-tailed table value for this data. I'm not asking you the two-tailed. I want to find only the right-tailed table value. How can I? How can I? Table value, right-tailed. This is for the two-tailed
Chi-square
test here.
cal is less
One
than.
minute, 1 minute. This is a two-tailed test. Now I'm asking for the right-tailed test. What is the table value? Is equal to
chi-inv.
CHI-INV, open the bracket.
Alpha.
Yes.
Alpha.
Alpha by 2 or all alpha?
Alpha.
Alpha.
Alpha, comma, degrees of freedom. Close the bracket. Enter. Got it. Now suppose if I'm asking you to find the left tail table value, then what is the table value? Is equal to
Chi-inv of
Okay, phi INV of
1 minus
1
alpha.
minus alpha by 2,
1
comma, degrees of
minus
freedom.
alpha by 2.
1
I'm
minus
asking
alpha.
Alpha.
1 minus alpha, comma, degrees of
Degrees.
freedom. Okay, is it clear?
Yes, ma'am.
Yeah, any doubt anywhere? Is it clear, everybody?
Yes, ma'am.
Yes, ma'am.
Yeah.
Yes,
In the
ma'am.
next class, I'll explain this chi-square test for independence of attribute and for the variance test, F test for with raw data, without raw data. That's it. Very simple. These three do. It doesn't take maximum. I guess in a 10 to 15 minutes we can finish it off. So please join the class, and in 10 minutes we'll finish this one and we'll stop the class. Is it clear?
Yes, ma'am.
Yeah. Please after the
Yes,
class
ma'am.
practice. Okay, this sheet, whatever I'm doing in this sheet I'll be sharing with you, and please practice this